All right, guys, so we're going to look at this example about a block sitting at rest on a ramp. The ramp has a 30-degree angle with the horizontal, and the question is, what is the minimum amount of friction that must be present? Now, we don't know a lot about friction yet, but we do know that it's a force. All right, we do know that that force can act to kind of oppose motion. So let's see if we can address this problem. Now, the first thing that would be helpful is to draw a quick picture. So let's do it. There we go. So we've got a block on the ramp. We've got our 30-degree angle. We do know that the block is 3.0 kilograms. At this point, because it's talking about friction, we do know that we're thinking about some forces here. Friction, of course, being a force, should make us think about Newton's second law and balancing the forces, especially because it's at rest. That means, according to Newton's first law, an object will only maintain its state of motion if the forces are balanced. So let's think about the forces. What are the forces acting on this block? You could draw a separate free body diagram if you want. Here is also fine. We've got the force of gravity, which is pulling down on the block. Hopefully you recognize that we have a normal force of the ramp pushing up perpendicular to the surface. Remember, that's what normal means. Normal means perpendicular to the surface, so it's got to be perpendicular to the surface here. And then last of all, we should have some friction. Now, if there was no friction, the block should slide down the ramp in this direction. So what that means is that the friction must be stopping that from happening. So friction is going to be kind of up and to the left in that direction, just like that. And there's nothing else touching it. We have no other at a distance forces. And so these are the only forces that we need to be able to deal with here. Now, at this point, I'm going to make a suggestion. Okay? Now, on a ramp, if it were to be left the way that it is, if there was no friction, we understand that the acceleration would be down the ramp. And even if there was friction, there's a good chance that in some situations we're going to be able to have acceleration down the ramp. Now, anytime that your acceleration is at an angle, not horizontal or vertical, then it's a good idea to take your ramp and put it at an angle, to tilt your axes, all right? And so our horizontal axis usually goes side to side like this, but instead I'm going to make my horizontal x-axis go this way. Now you'll notice that what that does, putting my horizontal axis that way, makes friction parallel to that. And it also makes, if there were an acceleration, if my block were moving down the ramp, the acceleration would also be parallel to that. Now remember, when things aren't parallel, when they're at an angle, we have to use trig to get components. This is going to simplify our life a little bit by meaning that we don't need to find components for friction or for the acceleration. Even though they look like they're at an angle, I'm going to make them be along the x-axis here. Now, of course, if the x-axis is parallel to the surface, then the y-axis should be perpendicular to the surface. And what you see now is that the normal force is going to be right along that y-axis. Now, the only force that isn't is now gravity. But of course, gravity, remember, we usually know that because we can calculate gravity by doing m times g, which we know the mass here. Usually that's something that we can measure. And g, of course, is the gravitational acceleration or the gravitational field strength, which are the same thing. So at this point, we're ready to start doing our equations. So let's go ahead and first we're going to do the horizontal forces. And I'm going to write them both out first. So horizontal, it looks like we're going to do, of course, sum of the forces equals MA. Now I've got no force here, right? That's just my x-axis. I've got negative friction there, so I'm going to put negative F. And then my gravity, of course, needs to have components along my new x and y axes. Now, sometimes students get a little bit confused about this because they try to draw horizontal and vertical components. But remember, my horizontal needs to be parallel to my x, and my vertical needs to go along the y-axis there. So it should be something like this. Now, one thing that you should note is that this angle right here, that is 30 degrees. Okay, now why? Well, you could do that using some trig. You could use some trig. You'd find that this is 60. We know that that's a right angle between the x-axis and the y-axis, so that would be 60 and 30 would give us 90, so that's 30 degrees. You can also think of it this way. Normally, gravity is straight up and down on my y-axis. Normally, my x-axis is horizontal. Now what's happening here is I'm taking my x-axis and I'm taking it from that horizontal and I'm rotating it 30 degrees, right? From here, it rotates 30 degrees. So my y-axis is usually here along my FG and I'm rotating it just like that, 30 degrees. So how far did I rotate it? I rotated it over right there, 30 degrees. And so that is 30 degrees. Now that makes this side right here be FG sine of 30. That's the opposite side. You can do the trig there if you want. And then this side right here would be FG cosine of 30. Again, you can do the trig with that angle, the opposite side, and the adjacent side. That would give you your two components here. Again, if you're having a difficult time with components, you probably want to go back and look at some of those other videos from earlier on this year that looked at components. So we've got friction, and then we've got this one. Now friction is actually going in the negative direction, so we already put the negative there. This one, this is horizontal, and it is going down to the right. We're calling that to the right here. And so that'll be a plus FG sine 30, which will be equal to the mass times the acceleration. We did say it's at rest, which means no acceleration there. And so we should actually be able to solve for the friction here. We can put in Fg, which is just mg, and we can solve for friction. Before I do that, I do just kind of want to show you, I can do something for the vertical forces as well. Again, we're doing sum of the forces equals ma. Now, if this is confusing, having sum of the forces there, you can label this as the force and the acceleration in the x direction, which is this right here, and the force and the acceleration in the y direction, which is those guys right there. Now in the y direction, we do have the normal force, which is on the positive y-axis, and then we've got the minus Fg cosine 30, which is down here. Now hopefully you're being able to see how simple this is compared to trying to find components of friction, trying to find components of the normal force, and possibly finding components of the acceleration if it was accelerating down the ramp. So on a ramp, if the acceleration would be down towards the middle, you definitely want to tilt your axis so that it is parallel to the surface of the ramp. Of course, this is also going to just be equal to 0 because it's not accelerating vertically at all. If it was accelerating down the ramp, this would still be an acceleration of 0 because it's only accelerating in the x direction. This would have a number that would still be 0. Again, one of the advantages of tilting our axis. Now at this point, you should be able to put some numbers in. I'd like to encourage you to try to pause it. I'm going to speed up the video here as I throw in the numbers, but hopefully you'll be able to calculate friction, and also, even though it's not asking for it, you should be able to calculate the normal force as well. All right? And there we go. We found out that friction is 14.7 and the normal force is 25.5 newtons. Now, one of the things that's going to happen if we've done all our signs correctly is that our answers should always come out as positive. If they come out as negative, it just means that we chose the wrong direction up here. Now, because I made friction negative here, saying that it was going to go in the left direction, getting a positive value here means that a positive value there would result in a negative friction going up the ramp. Okay, same thing with the normal force. The normal force was positive, so the fact that I got a positive number just means that it is positive as I expected when I put it into the equation. So there we go. We were able to find the minimum amount of friction. Along the way, we were able to find the normal force that's there as well. That's another question that could be asked of you. And we were able to finish up the question and use kind of this new little trick in being able to solve Newton's second law questions. All right, hopefully that was helpful. I'll see you in class.